Here for the pros and cons of a monolith. First, the pros. Convenient for new projects. Usually, when you're just getting started, a monolith is the best option since you can put all the source code in one place, including all common libraries. This lets you iterate quickly for a while. Tools mostly focus on them. Most IDEs are built around the concept of building a single application, which aligns pretty well with a monolith. There's great code reuse. Since all the code lives in the same repository, it is easy to reuse code across the multiple models of the application. It is easier to run locally. Being a single process, it is straightforward to have the full application running in your box, usually with a single command. Easier to debug and troubleshoot. When it's time to fix bugs, there's usually a single place to look for logs to find out what happened. You can also start a debugging session in your box to reproduce and fix the issue. There's one thing to build. A single command is usually enough to build the entire code base locally, and if using a continuous integration server, a single build pipeline will do the trick. There's also one thing to deploy. All the application models can be deployed as a unit with a single deployment pipeline. There's one thing to test end-to-end. End-to-end verification of the application can take place as soon as the application has been deployed, with no other moving pieces that could impact testing. And there's one thing to scale. When the increased load demands more instances of the web application, there's only one app to scale. Saying when the increased scale is no longer needed, there's only one thing to scale down. Now, the cons. Easily to get complex to understand. Since the entire code base is in a single place, there will be a point where it starts becoming too hard to navigate it and understand the relationships between the different components. Merging code can be challenging. When using things like Git, and with more and more people contributing to multiple models in a single code base, eventually resolving conflicts gets more troublesome, and the chances of a bad merge that could impact unrelated models increases. It slows down IDEs. If the devs use an integrated development environment or IDE like Visual Studio, the massive number of projects and source code will eventually start slowing down the IDE, starting with simple things such as opening the work environment. Long build times. The bigger the single code base becomes, the more time it takes to build it. Things like incremental builds can help here, but this is something that can easily not be configured properly, and regardless, it is undesired to have to build code for all the application models when usually you only work on one or two of them. Slow and infrequent deployments. Just like building the code takes longer, it also takes more time to complete the deployment, since there are a lot of components to deploy with every new build. Not only that, teams tend to delay deployments to Friday night or even weekends due to the lack of confidence on the impact of the changes that go into that deployment. Remember that with each deployment, you are deploying all the application models all the time. Long testing and stabilization periods. Once a deployment is complete, regardless of what changed in the deployment, you still need to test all the scenarios across all of the application models. Not only this is inefficient, but also teams that don't have testing fully automated may need to run manual tests to compensate and run them again for all the application scenarios. Rolling back is all or nothing. Bugs will eventually make their way to deployment, and sometimes there's no time to code and deploy the ideal fix. In these cases, you just want to roll back to a previous version. However, with a monolith, you will be forced to roll back the entire application, not just the faulty model. And once the fix arrives, you will need to redeploy the entire thing again, with all the associated testing and stabilization. No isolation between models. The smallest bug in one of the models that makes the web application crash will take down all the models with it. It can be hard to scale. This really depends on the kind of app that you're building, but if you have some model that needs, say, a lot of memory and therefore needs to be scaled to multiple instances to not take over all the RAM in a single server, while all the other models are fine with a small amount of RAM most of the time, you still need to scale the entire application with all the models to satisfy the RAM needs of the first model. Also, it's hard to adopt new tech. If you would like to move one or two of the models to the latest version of, say, the .NET platform, you are forced to update all the models along with it, which significantly increases the time investment and the associated risk of moving to a new stack. Moreover, if you need to switch a module to a different programming language or web framework, you still need to account for how that change will impact the rest of the modules. In the next lesson, we will start learning about microservices, their pros and cons, and when it's a good time to start considering them.